Let's pick up with limiting reactant problems. And here's a very good example of a typical limiting reactant problem. When 123.4 grams of propane, which we know is C3H8, and 247.3 grams of oxygen are allowed to react, how many grams of carbon dioxide can be formed? What is the limiting reactant? How many grams of the excess reactant are left over? Okay, and I guess the one thing that's different than how this could appear on your quiz or exam is that on your exam, you would have a balanced combustion reaction for this process. I wouldn't ask you to write the reaction and solve this problem typically on the same exam question. So I'll put the balanced reaction that we worked out before up here. One mole of propane plus 5 moles of oxygen goes to 3 moles of carbon dioxide and 4 moles of H2O gas, water vapor. We're going to need that. So the first thing we're going to do is we're going to find the limiting reactant and the amount of product that can be made. And this problem is directing us towards the product of interest, which is carbon dioxide. Sometimes I don't tell you, I just ask for the limiting reactant, and you get to choose which product you're going to. But since this problem calls out carbon dioxide, we will do our calculations towards carbon dioxide. We will take each of the grams of propane and the grams of oxygen and do stoichiometry towards finding the products. I'll start with my grams of propane. And again, this is very typical stoichiometry. We're going to take grams, turn them into moles. For propane, we know that there are 3 moles of carbon, 12.01, plus 8 moles of hydrogen. We add that up to get the molar mass. Molar mass for propane is 44.09 grams of propane per mole. And in the picket fence, my technique for doing unit conversions and what we call stoichiometry or reaction stoichiometry unit conversions, I put the molar mass here with grams on the bottom, so my grams of propane cancel. The next step is always a mole to mole conversion factor. And a mole to mole conversion factor always involves coefficients. What I mean by that is the reaction tells us that for every 1 mole of propane, there are 3 moles of carbon dioxide that are produced. And finally, to calculate my grams of carbon dioxide, I know that for every 1 mole of carbon dioxide, the molar mass is 44.01, and that's grams of carbon dioxide. So that's my setup. If I multiply all this out, 123.4 multiplied times 3 times 44.01 divided by all the numbers on the bottom, I get 369.5 or 369 to 3 sig figs. Oh, I have 4 sig figs here. So let's go 369.5. 3 would be fine. Grams CO2 if propane is the limiting reactant. And here I use the abbreviation LR for limiting reactant. Now we'll do the same thing again for oxygen. And oxygen, 32.00 grams per mole. Takes 5 moles of oxygen reacted to make or produce 3 moles of carbon dioxide. And my last step is always the same for this part. Lots of ways to do limiting reactant problems. This is mine. Make sure you find yours. Multiply by the numbers across the top, 247.3 times 3 times 44.01 divided by 32 divided by 5. And I get 204.1 grams of CO2 if oxygen is the limiting reactant. When what this says is, since this number is smaller, it means that the smaller amount of carbon dioxide is the amount we can make, and that we are going to run out of oxygen first. So the fact that this is the smaller number means that this is the amount of carbon dioxide we can make. So amount of carbon dioxide that can be made. It's also called the theoretical amount, or the theoretical yield. And O2 is the limiting reactants. Okay, come back to my question. How many grams of carbon dioxide can be formed? 204.1. What is the limiting reactant? O2 is the limiting reactant. How many grams of the excess reactant are left over? For that, we'll go to the next slide. Actually, before we do that, this amount of oxygen is totally consumed, so because that's what being the limiting reactant means. There'll be none left. This amount of oxygen was reacted. 204.1 grams of carbon dioxide are produced. These are real numbers for this reaction. This is a calculation that we did for comparison purposes. So we cannot use this number of grams in any other calculations. The only calculation we can use this number for is to find out how much propane is used up, given that this is the starting amount. So key in on the limiting reactant, grams, or whatever it is, as how you want to move forward with all other calculations. So when I do how many grams of the excess reactant are left over, I am coming back to this number. Okay. Now let's find the amount of the excess reactant that is left over. Our process goes something like this. We know that we started with 123.4 grams of propane. And I guess I should say, we know that propane is our excess reactant because it was not all used up. So only two choices here, limiting and excess. So the excess reactant. Now we have to find the amount of propane that was reacted away. The technique we're going to use for that is we're going to come back to our 247.3 grams of oxygen, which we know reacted. We're going to do stoichiometry this time to propane, and here's what that looks like. So 247.3 starts off the same. Then for every 5 moles of oxygen, 1 mole of propane. So this is again our mole-to-mole ratio conversion factor using coefficients. It says that for every 5 moles of oxygen that are reacted away, 1 mole of propane is also reacted away. And for propane, we already used its molar mass, 44.09. Now we're ready to rock and roll. Or, as I like to say, as a chemical engineer, plug and chug, plug the numbers into my calculator and chug along the train tracks to the answer. Ones and ones, so times 44.09 divided by 32 divided by 5. 68.15 grams of propane reacted away. Clearly, this number needs to be less than the amount we started with if our calculations are going to work. And so if this number were a bit larger than 123.4, it would suggest that we need to revisit our calculations. All right, so let's see, we have start with, we have reacted away. So the leftover amount is start with minus reacted away. And again, I still like to stack them up so I can think of sig figs. 123.4 minus 68.15. I get 55.25. And then we'll always use 3 sig figs. That's how we know that 55.3 grams are okay. But if we stack them up, we'll see that the smallest number of decimal places for addition and subtraction is 1. And so always nice to check in with our sig fig rules anyway. 55.3 grams of propane left over. And as we always come back to the question, what is the limiting reactant? Oxygen. How many grams of carbon dioxide can be formed? Right here. How many grams of the excess reactant are left over? We have answered this question.